Let's start with the variable. So in the last, means yesterday's class, we talked about that how we can give the values to the variable and what that variable is. So here, see, in the R language, unlike other languages, in the R language, we doesn't have to give the data type of that particular variable. Okay. So let's say if we have a variable, let's say var, and in this particular variable, let's say we are putting some values. Okay, let's say equal to 10. So right now what it is doing is taking the numeric value here, and when we run this, so what will happen is a variable will be created with the value 10. The same variable, I can give some sort of character or a string also, right? So I can provide some sort of character, right, in the same variable, right? So this variable value has been changed right now from 10 to A. Let's say we want to give some sort of a string, right? So it is giving some string value here. So what I want to tell you is the type of the variable in R is a dynamic. So it is of dynamic type. It means that whatever the type of variable is, it doesn't matter to it. Now, in your simple C, C++ or Java languages, it is highly defined, highly based on the type that will define. So let's say in the C++, how we write, let's say I want to give 10 to X. So I'll write int X equal to 10, right? So this is the way how I can write it. Now, before that, if this is like happen in C, C++. Now here in R, I can give only X equal to 10. But here the declaration and definition is at once, right? Here in this particular part, I can write like this. I can write int X, and then X will be equal to 10, right? So this is the declaration of the variable, and this is how we define the variable. So whenever we declare the variable, at the time of declaration, the memory will be allocated to X. And after that, we are putting the value to X. Now, in terms of R or other languages like Python or PHP, where this dynamic type will be given to the variable, here this X equal to 10, that particular point only the memory will be allocated to X, and based on the data type of X will be defined. Okay, so this is happening in the R. So that's why it is of dynamic type. Okay, that's why it is called, R language is called dynamically typed language. Now, in the last class also, we have discussed about the assignment operator. Means I can assign the variable like this. This is also correct, right? Or I can assign the variable at that particular form. So in that way, I have to give this particular value in the left-hand side and this var in the right-hand side. So let's say if I want to give some other value to it. See? So generally, most of the R developer follow that particular way of writing the variable or the assigning the variable. Okay, this is most of are following this. If you are not habitually of that, you can use equal to. Okay, So equal to as an assignment operator. This is also assignment, this is also assignment, and the equal to is also an assignment, right? Now let's talk more about the variable. R support three way of variable assignment. That thing we have already been seen. Will not look again. Now here we'll see that what are the nomenclature of R variable. Means whenever we want to give the variable name, whether it is the name of any object or any function or any sort of variable, that is called identifier. So how we can give the name to the identifier, right? How we can give the name to the identifier. So here we have some rules that need to be followed. It says that a valid variable name consists of a combination of alphabets, numbers, dots, and underscore character. For example, var.1 underscore is valid. Now here you just see whatever name we'll give, if it is starting from the alphabet, it is okay. If it is starting with the dot, then we have to look for, like, we haven't put the any sort of number. But if it is starting from the alphabet, then there is no problem with that. Now once we start with the alphabet, and when we want to give any special character, so we have two type of special character here. One, we can use dot, another we can use underscore. So these two are the special character we can use along with the variable. Apart from the dot and underscore operator, no other special character is allowed. So for example, let's say we have given the alphabet and the dollar symbol, then this dollar symbol is not going to be used, or hash is not going to be used. So any other special character other than dot and underscore will not be accepted. Variable can start with alphabet or dot character. So these two are the ways. Underscore could not be started. It might be start from dot or alphabet. Now, if it is starting from dot, so we have to make sure that after dot, there should not be any numeric value. And if it is a character, then it is okay. The variable should not start with a number or underscore, right? So if a variable is there, it should not start with the number or underscore. So I cannot give like this and then this. So this is not the right way to do it. So for example, 2var or underscore var is invalid, In a variable starting with dot, the next thing about after the dot cannot be the number. So in this way also is invalid. So dot 3 and then means after the dot, if any numeric number will be there, then it is invalid. Okay. Now let's see all those things with the help of the R Studio here. Now, if we have the variable, okay, so it is a valid one. Okay. Now, if we have a variable like this type of dot var and we are putting some value there, then it is also, there will be no issue on that. Okay. Now, if we have like a dot and then 3 and then we are giving some value, then it will be an issue here. Okay. So it is giving you some unexpected token VR. In that way, it is giving you some exception, right? So these two, there is no issue on running it. So it will run and the variable will be created. So here we have another variable is there, VR. Yeah, it is printing its value. Now, if we are going to run this, then that is saying that unexpected symbol in .3 var. So that symbol is not going to accept it. As well as if you are starting anything with underscore, then it is also not a variable. It is also not a variable, and it will produce some sort of problem. Okay. So this var is also having the problem, and it is also, this is saying unexpected token, right? So for the variable, these are all different type of what we can say uh, constraints are there that we need to be followed. Now here, if we'll write any type of spatial symbol, then it is also creating the problem unexpected token. Again, it is coming, okay? And it is giving this cross symbol unexpected token in that. So all those are the valid one, the valid one, and these are the invalid one. So I hope you understood while giving the variable name or by giving any type of identifier what we have to do. Now there are different methods related to the variable. One method is called class method. Class will give you the class in which that particular variable is belongs to. Okay, so let's say if we have a variable b1, okay, or let's say if I'll say simple x, and x has given some value, let's say 30, okay, or I can give it here. This is not shown. Let's say if x equal to 30, so x variable has been created here. Now if I want to find out the class of it, so class of x, so what is the class of x here? The class of x, it is saying numeric class. So the class function will tell us in which particular data type class that variable belongs to. So it belongs to the numeric data type class. Okay. At the same way, if we have, let's say, x equal to some sort of character like this, then and when we want to find out its class, then it is giving you character. So it is of character type, right? The same thing if I am putting like this. And let's say we'll find out the class of it. So it is also comes under the character type. Okay, so here we have the different type of data type. We'll see just now very shortly what are the different data type we have and how we can find out their class, in which class that particular data belongs to. Because by looking it, we doesn't have specified any class of it or what type of data type it is. We haven't defined it. So R has given a method to find out that. Now we have another function which is called ls function. Ls function is the built-in function, is used to know all the present variable in the work space. This is generally useful when dealing with large number of variable at once and help preventing overriding any of them. So ls is very much useful when we have different type of variable with us, and we want to know that what are the different variable we have. Okay, so in that aspect, this ls is going to help. So let's take this particular code here. Now here we have variable 1, which is the name, the value here is hello. Variable 2, again the value is hello. Variable 3, again, the value is hello. And we are printing ls function. Now, ls will give you all the variable which are present. So you just have to run that. Now, if you'll see, we have variable 1, variable 2, and variable 3, 1, 2, and 3. And you see output of ls is, it is giving you the list of all the variables which are present in the workspace. So right now we have variable 1, variable 2, and variable 3 present in the workspace. So it is giving you the variable name, what are variable name which are present. Now we have another function related to the variable, which is called rm function. It is again a built-in function used to delete an unwanted variable within your workspace. Let's say you have created a variable which you do not want at the later portion of your program, so you can delete it. This helps clear the memory space allocated to certain variable that are not in use, thereby creating one space for other. The name of the variable to be deleted is passed as an argument. So whatever variable you want to delete, you just pass that particular name into the uh, rm function. So if we'll say this, so okay, so am I audible to everyone, or there is any issue in the audio? Okay, good. Okay, good, good. Okay, so this particular program is creating three variable, right? So when we run that, it is creating three variable, where one, where two, and where three. Okay. Now what we do is we'll use the rm function, and we remove one of the variable. Let's say we are removing variable 1. Okay. So if we'll remove the variable 1, after that, see, variable 1 has been removed from here. And after that, let's say I want to list out all the variable which are present right now. So it should give me only two variable, variable 2 and variable 3. In that way, this rm function is working here. Now let's talk about the scope of the variable. Okay. The location where we find a variable and also access it for required is called the scope of the variable. There are mainly two type of variable scopes. Now, in just like we have like C, C++, where inside a particular scope, we can access the variable. After that, we cannot access it. And if it is a global variable, we can access throughout the program. The same, more or less same concept is applied here also in R. We have two type of variable, global variable and local variable here. Now, global variable are those variable that exist throughout the execution of the program. It can be changed and accessed from any part of the program. So we can change as well as we can access it from any part of the program if we have created any global variable. As the name suggests, global variable can access from any part of the program. They are available throughout the lifetime of the program. They are declared anywhere in the program outside all the functions or blocks. So if there is a function or the block, so the global variable we have to put outside to any function or any blocks. Declaring global variable are usually declared outside of all the functions in the block. They can be accessed from any portion of the program. So let's take this particular example. Now we have a variable, which the name of the variable is global equal to 5. This global variable will access within a function. So here we have created a function which is called display function. Inside that there is no argument, and the definition is it is going to print the global variable, right? And when we are calling that particular function, it is calling the definition of it and it is printing it. Now after calling, we have changed the value to 10 and again call the display function. So one display function is going to print the value as 5, another will going to print value as 10. So one display is printing value as 5, another display is printing value as 10. Okay, so the same thing is there. Whatever we have learned in other languages, the same has been applied here. Here the environment, it is saying that the value variable here is the global variable, the value is 10, and we have a function and the name of the function is display and it is of function type. Okay. Now, let's talk about the local variable. So local variable are those variables that exist only within a certain part of the program. So in a certain part of the program, that local variable will be there. So definitely there will be some scope, and inside the scope, the variable will be accessed. Those scope will be that variable will be accessed only on that particular scope. So that's why it comes into the category of local variable. So the program like a function and are released when the function call ends. Local variable do not exist outside the block in which they are declared. That is, you cannot be accessed or used outside the block. Now, in this particular example, if you can see, so we have a function, and inside the function, the issue here. Okay. Okay, so we have this function. This variable is local to function and cannot be accessed outside the function here. Now, so we have this variable called age, and this age is local here. And through the function only we can access it. Okay, let's run this. So it is, the function is displaying the value here. Okay, value as 18 here, and it will be now if I want to use the value of that particular age. Let's say I want to change the value of age to 30, and if I again call this particular function, so what will happen here? Now this age and this age will be completely different. Okay, so let us run this once again. Now you'll find out after this age, this particular age, Now this age is the global one, and this particular age is the local one. So when I call the function, it is getting that particular age. And even though I have given the other value to age, it is still printing 18. So it is only accessing this particular age. It is not accessing this age.